Hello everyone, welcome back to my YouTube channel. So this is the video lecture on module number 3, that is second part of module number 3 of digital switching system. The second part is having a title as a switching system. The meaning is we'll be discussing about switching systems over here. So in this video lecture, we'll be discussing about introduction to switching systems and single stage networks we'll be discussing. Fine. Okay, so let us go into details of this. This is your syllabus copy. So module number three, first half is over. The second half is switching systems, and that we'll be discussing introduction of that's what I already said. So let us go into details of that. Okay, so switching systems. Now, introduction to this. The basic requirement for constructing switching systems, such as telephone exchanges, is to be able to design switching networks having a greater number of outlets than the switches from which they are built. That is, what he's trying to say is we should make our system able, okay, to design the networks that having a greater number of outlets than the switches from which they are built. So number of outlets should be more compared to the number of switches from which they are built. Okay, this can be done by connecting number of switching stages in tandem. So this is achieved by connecting a number of switching stages in the tandem. Fine. And he's taking one example of a Strauger exchange that we discussed in the previous modules, that using that it can give us up to 10,000 line terminations by using 3 trunks of 100 outlet selectors. Fine. So in the Strauger system, there were 100 outlet system. Such 100 we had 3 sets of such 100 outlets that could able to give a 10,000 line terminations. Fine. And further we have discussed a two-stage network also, which is giving us the access up to 100 outgoing trunks and so on and so forth. Fine. So this is our main aim over here. If the number of trunks, whatever number of switches what we have, the outgoing lines should be more than the number of trunks that we have. So that is the main aim of designing any switching network. That is what he is trying to say. Okay. So the second topic to be discussed over here is single stage networks. So in this single stage network, he is considering the 3.11. 3.11 is the matrix of Crosspoint that we discussed in the previous module, fine, which was having m inlets and n number of outlets. Fine. About this, he's taking this and he's explaining over here. And the figure 3.11, that is this figure, that is matrix of cross points. It shows a single stage network having m inlets and n outlets. Number of inlets are m and number of outlets are n, consisting of a matrix of cross points. You can see over here you have each and every corner over here we have a cross points, right? So it is having a matrix of cross points. So these may for example be separated, maybe separate relay or electronic devices or the contacts of crossbar switch. These cross points may be made by electronic switch or any other system, electromechanical system. That is what he is trying to say. Network could also be constructed. The same network can also be constructed by making use of, by multiplexing of banks of m uniselectors or one level of a group of m2 motion selectors, each having n outlets. So it can also be designed by making use of, what he's trying to say is, m uniselectors or one level of a group of 2 motion selectors. We can either use a uniselector or 2 motion selectors, each having n outlets correspondingly. Okay. So future systems may employ photonic switches. The normal switches were replaced by photonic switches in the future system. That is what he's trying to say, in which optoelectronic devices are used as crosspoints to make connections between optical fiber trunks. These can be used in the optical fiber trunks as well. The network of figure 3.11, that is this matrix of cross points, may be represented in a simplified format by using a symbol shown over here. So those cross points are replaced by these symbols is trying to say. Okay. Now, thus here in this figure, we have a small circle over here, right? So what this circle says is, this circle indicates that the side of the switch associated with the control mechanism. For example, this the circle is there. The meaning is, whatever this arm is there, this switch is there, it can open and close. It is capable of moving. That is what he is trying to say. That is what this circle tells us. Fine. Now, the figure as shown, the switch shown in figure 3.1 gives full availability. That is the system that was designed by making use of M inlets and N outlets. That system, there was full availability was available. The meaning is, no calls are lost until and unless all the outgoing trunks are fully busy or congested. So till that time, it will be fully available. Meaning is, no calls will be lost at all. That is what he says. The number of simultaneous connections that can be made is either M or N. The number of simultaneous connections that can be made to the system is either M or N. Okay. The switch contains M into N. If the number of inlets is M, outlets is N, then number of switches will be M multiplied by N. That is what Mn is saying. Okay. If M is equal to N, if number of inlets and number of outlets are equal, okay, then the number of cross points will be N square. That is what he's trying to say. Fine. If they are not equal, number of cross points will be M into N. If they are equal, then we will be having number of cross points as N square. Fine. Thus, the cost increases as the square of the size of the switch increases. If let us say, for example, you have a 1000 by 1000 cross point inlets and outlet. Let us say you want to add 100 more. Then what happens? 100 inlets and 100 outlets has to be increased. 100 cross points has to be increased. So that is what he is trying to say. The cost is going to increase considerably. However, the efficiency decreases inversely with N. Efficiency will be decreasing inversely with the N. That is what he is trying to say. So the meaning is, if N increases, the efficiency will be decreases. Fine. So it is therefore uneconomic to use a single stage network for large number of inlets and outlets. So since the cost is more, what you can say is, this becomes an uneconomic. Fine. That is what he is taking one example to explain that. For example, a switch with 100 inlets and 100 outlets, it requires 10,000 cross points, and only 1% of these can be used at any time. Okay, that is a major problem over here. All the time, all the trunks, all the switches will not be busy. Only 1% will be busy. Only during the peak hour or a busy hour, all will be busy. So, it is uneconomic to have such a big system. That is what he is trying to say. Switches of making connections between large number of trunks are therefore constructed as networks containing several stages of switches. Okay. If the switch shown in figure 3.1 is used to make connections between N similar circuits, then each circuit is connected to both inlet and outlet. That is, if this system is used, okay, if this system is used to make connection between N similar circuits. Okay, if N number of similar circuits you have, if you want to connect them together, then each circuit is to be connected both inlet and outlet, and the operation of the cross point at coordinates j comma k to connect j inlet j to outlet k thus performs the same function as operating cross points k comma j. That is what is trying to say is, if you have 10 by 20, okay, 10 is the inlet, 20 is the outlet, then 10 by 20 is equal to 20 by 10. That is j comma k is equal to k comma j. Fine. The number that is what he's saying is, operation of the cross point at coordinates j comma k to connect inlet j to k outlet thus perform the same function that is performed by a system having k comma j to connect k to j outlet. Okay. Consequently, what is the half of the cross points are redundant. Half of the cross points that will be there in our system are redundant. Okay, the meaning is you'll be having excessive number, and those can be eliminated. Those redundant bits, those redundant cross points can be eliminated. If you eliminate that, what happens is that it will be economic. The switching system establishing cost will be reduced. Fine. This results in a triangular cross point matrix over here. So if you eliminate few of the switches that are redundant, then we'll get a special type of cross point connection that is called as triangular cross point matrix. And this triangular cross point matrix is economic. Cost of this is less compared to the other system. Okay, the number of cross points required in this cross point system is given by 1 by 2 times n into n minus 1. Let us say if n is 100, 100 into bracket 100 minus 1, it is 99. 100 into 99 divided by 2. Half of that will be the number of cross points required. Okay. The triangular switches are not usually found in telephone switching systems because both way trunks are not used. There is one limitation over here. Here we cannot use both way trunks. This is the reason this cross point switching system is not used in a telephone switching systems. Rather, the trunks are operated on a one-way basis to facilitate supervision. This can be used for supervision purpose. For example, ringtone and ringing currents are sent over the separate one-way trunks depending on whether customer's line is calling or being called. Such a kind of systems are used for monitoring. Monitoring in the sense sending the ringing tone and ringing current are for sending these things we can use this cross point connection. That is what he's trying to say. Okay. So this is all about our first topic to be discussed, that is after introduction, that is single stage network. Thank you.